Good afternoon to Ananda. This is Gopi Krishna, Assistant Professor, Department of CSC from Chevrolet Engineering College. So, subject is compiler design, and today's topic is phases are a structure of a compiler. Okay, what is the topic? Phases are structure of a compiler. So, in previous class, we are discussing. So, what are the types of compilers and what is the language processing system? Okay, so in what are the types of compilers? So based on passes, we have three types of compilers, and based on functionality, we have different six types of compilers. So those are based on passes. So three. We have we have three
Compilers.
compilers. So first one single pass compiler, second one two pass compiler, third one multi pass compiler.
Multipath
So
compiler.
and based on the functionality, we have six types of compilers. So those are native code compiler, cross compiler, source to source compiler, and threaded code compiler. So next one incremental, and finally source compiler. So these are the types of compilers based on passes and based on the functionality. Okay, so what is single pass, what is two pass? Okay, already in previous class we are discussing. And what is the language processing system? So in language processing system are cousins of a compiler. So language processing system we are taking. So we have take the one source program. Okay, so a source program is that is delivered to the preprocessor. So the source program means so we are writing a program in a high level language. So that is input to the preprocessor. That preprocessor can be converted thus high level program into pure high level language program. Okay, so preprocessor, so what is the work done by the, so what is the role of a preprocessor? So the role of preprocessor is so we are eliminating the uh, that are present in a comment line statements that are present in a program that can be removed by the preprocessor. And is there any spaces that are present in a program that can be removed by the preprocessor? And another one, so is there any errors? Okay, is there any errors that are present in a program that is notified the compiler? Okay, so preprocessor, what is the work of preprocessor? So we are using preprocessor. We can remove the comment line statements, and we are producing macro processing. So macro processing means the entire program is divided into small programs. So that is the micro processing. And file inclusion session. So is there any files can be included? They So, is there any file inclusion sessions? Those inclusion sessions are that can be that can be carried by and added to the source program. So that is the work done by the preprocessor. So what is the role of preprocessor? So we are removing the comment line statements. We are removing the comment lines, and we are having any white spaces that are present in a program that can be removed by the preprocessor. And is there any file inclusion? That means is there any header files or preprocessor directives? So those can be included to the source program. So the roles done by the preprocessor, the high level language is converted into pure high level language. So that is the first one. So the pure high level language is input to the compiler. That compiler compiles the that particular pure high level language program, source program, and it is converted into assembly level language. So that is the work done by the compiler. So in this compiler we have any error messages. Those error messages can be notified to the programmer or a user. Okay, so that is the compiler. And what is the work done by the assembler? Assembler is used to convert the assembly level language into machine level language. So that is relocatable machine level language. Those relocatable machine level language by converting the assembler. And relocatable machine code that is assigned to the linker or loader. So what is the work done by the linker or loader? So what is linker? So is there any files can be included to that particular program? That files is included to linker. And what is the loader? So it is assigning memory to that particular program, and the program is ready to execution. So this is the language processing system. Finally we can get the absolute machine code. So this is the language processing system, or cousins of a compiler. So today topic is the general structure of a compiler, or the phases of a compiler. So here we have mainly two phases. So that is front end phase and back end phase. So here we are taking the front end, we have four phases, and we are considering back end, we have two phases. So here the first phase in front end, lexical analysis. 581, who is 581? 81.
సార్ సారీ సార్ మిస్టేక్ గా పడింది.
అందరు మ్యూట్ చేసుకోండి, ఏమైనా డౌట్స్ ఉంటేనే అన్మ్యూట్ చేసుకోండి. ఓకే, so the general structure of a compiler. So this is the front end. So the first phase of phases of compiler is lexical analysis. So what is the lexical analysis? So it is also known as the scanning phase. Okay, so one source program is taken as input to the lexical analysis. Those source program is converted. So read each and every character from the source program and group them into one meaningful tokens. So those tokens are called the lexemes. So we are reading a source program. So we are reading lexical analysis. What is the role of lexical analysis? So we are reading each and every character from the source language and grouping them into meaningful order. Those meaningful characters are called the lexemes. So those lexemes are present in a lexical analysis. So in this lexical analysis, we are converting group of characters into stream of tokens. So that is the role of lexical analysis. So the output of lexical analysis is taken as the input to the syntax analysis. So in this lexical analysis, we are converting stream of tokens. So that is the input to the syntax analysis. In this syntax analysis, we are converting that stream of tokens into construction of parse tree. So what is parsing? So we are reading, we are construction of a tree like root node and leaf nodes. So that is the parse tree. So in constructing of a parse tree, in syntax analysis, can get the stream of tokens from the lexical analysis, and it is syntax analysis is converted those stream of tokens into parse tree or syntax tree. So syntax analysis is also known as the parsing phase. Okay, so second phase. And what is the third phase? Semantic analysis. The output of syntax analysis. So what is the output of syntax analysis? It is the parse tree or syntax tree, and it is taken as input to the semantic analysis. And in this semantic analysis, what is the role of semantic analysis? Means so the syntax tree from the syntax analysis is semantically verified. That means we are constructing a syntax tree or parse tree. Is it is a correct one or not? Why? Because so we are constructing a syntax tree or parse tree. It is very easy. So in this syntax tree or parse tree construction, we have more than one derivation. So leftmost derivation, rightmost derivation. So in this way, we are constructing more than one derivation, that is ambiguity. So we are removing the ambiguity of a syntax tree. So that is the semantic analysis. So those verification can be done by the semantic analysis. So the given parse tree is semantically verified or not. So this is the semantic analysis phase. So the third one. And what is the fourth one? Intermediate code generation. So the output of semantic analysis. So what is the output of semantic analysis? The syntax tree or parse tree is syntactically verified. That means the parse tree is correct one or not. So if it is correct, then it is transferred to the intermediate code generation. If it is not correct, then intimate to the syntax analysis. We can construct again a parse tree. Okay. So intermediate code generation, the output of semantic analysis. So that is given to the intermediate code generation. So intermediate code generation means so a given syntax tree or parse tree, we are generating intermediate code. So the best example for the intermediate code generation is tree address code. So that is we are having any statement with four identifiers. So it is four address code. We can convert that four address code into tree address code. So that is the intermediate code generation, and the output of intermediate code generation, the output of intermediate code generation, that intermediate code is having a three address code. That is given to the input to the code optimization. So what is the code optimization phase? So it is the backend of phases. So in backend we are two phases: optimization phase and code generation. So code optimization and code generation, these two are the backend of a structure of a compiler. So code optimization, we can get the input output from the intermediate code generation. It is taken the input, and the code optimization, we can remove any unwanted code. That means the three address code, there is any unwanted code that is removed by the code optimization. For example, we are writing a is equals to b plus c into d. So that is we are writing a is equals to b in b plus c into d. We are writing t1. So T1 is equals to C into D, and T2 is equals to A is equals to T2 into T2 plus T1. So in this way we are writing three address codes. So is there any unwanted statements that are present in a intermediate code generation? Those unwanted statements can be removed by the code optimization. So this is the fifth phase of a compiler. And what is the next one? So code generation. So optimization means we can remove any unwanted statements that are present in the intermediate code generation. So optimization is removing so unwanted statements, and the output of code optimization, that is given to the code generation. So here code generation, finally the last phase of compiler is 503. Chapamma.
వాయిస్ ప్రాపర్లీ లేదు సార్.
వాయిసా ఇప్పుడు
ఇప్పుడు పర్లేదు సార్, అక్కడక్కడ అవుతుంది, రావట్లేదు సార్.
ఓకే ఓకే, సిగ్నల్ డ్రాప్ అవుతా ఉండండి. సో అర్థం కాకపోతే అడగండి. రైట్, ఇప్పుడు వస్తుందా? ఓకే. సో దిస్ ఇస్ ద లాస్ట్ phase of code generation. So the output of code optimization. So that means that is any unwanted statements that are present in a code, that is removed by the code optimization, and that is given to the input to the code generation. So finally code generation is the last phase of a compiler. So this is the last phase. We can convert that the statements into the target language. So what is the target language? So it is in the low level language, that is assembly level language. సో కంపైలర్ మనం తీసుకుంటే ఓన్లీ ద సోర్స్ ప్రోగ్రామ్ నుంచి, అంటే హై లెవెల్ లాంగ్వేజ్ దట్ ఈస్ కన్వర్టెడ్ ఇంటూ high level language is converted into low level language. So high level language is a source program English language, and low level language is a assembly level language, right? So here the lexical analysis is used to convert the high level language into low level language. So that is the work done by the compiler. So these six are the phases. Okay. So these six phases can be used to generate any new compiler. So we are using these four pages in same in every creation of a compiler. So we can modify the last two pages. We can get a new compiler. So these are the six pages of compiler or general structure of a compiler. So these six pages are communicated with the symbol table and error handler. So these are the pages of a compiler. So we can discuss these pages in detail. So, so in first phase is lexical analysis. So in this lexical analysis phase, right. So in this lexical analysis phase, so what is the lexical analysis is also known as the scanning phase. Okay. So in this scanning phase or lexical analysis phase, so first we are taken input of source program. So that is a high level. We are writing a program in a high level language. So that language is reads lexical analysis. So we can read characters in the source program and group them into meaningful sequences. Okay. So what is that? We are reading a given source program. We can read each and every characters that are present in a source program and group them into meaningful sequences. So ఒక మీనింగ్ఫుల్ సీక్వెన్సెస్ వచ్చే విధంగా మనం ఆ క్యారెక్టర్స్ ని ఈచ్ అండ్ ఎవ్రీ క్యారెక్టర్ రీడ్ చేసి ఒక మీనింగ్ఫుల్ సీక్వెన్స్ వచ్చే విధంగా వాటిని గ్రూప్ చేస్తాము. సో దాట్ గ్రూప్స్ ఆర్ కాల్డ్ ద లెక్సీమ్స్. ఓకే. సో దిస్ ఈస్ ద one. So reads characters in the source program. So character means a single letter. So that reads characters in a source program and group them into meaningful sequences. Those sequences are called the lexemes. Okay. So first one is the so next produces as output a token of the form. So for example, we are producing as output. So we are taking the input, that is source program, and this source program is read each and every character and group them into meaningful sequences called lexemes. So those lexemes and produces output to the syntax analysis. Okay. So produces as output a token of the form. So this is the output of input to the syntax analysis. So token class comma attribute name. Okay. So this is the output of given and a group of characters we are dividing into it is in the form of token class and attribute and passes it to the next phase. So what is the next phase? So that is the syntax analysis. Okay. So this is first one, reads characters in the source program and group them into meaningful sequences called the lexemes, and we can generate a output of to the next phase, that is the syntax analysis. So that is the output is in the form of token class comma attribute. Okay. So here what is token class? The symbol for this token to be used during syntax analysis. So ఏవైతే సింబల్ ని మనం సింటాక్స్ అనాలిసిస్ లో యూజ్ చేస్తున్నామో ఆ సింబల్ ని జనరేట్ చేయడానికి మనం టోకెన్ క్లాస్ అనేది తీసుకుంటాం. సో వాట్ ఈస్ ద టోకెన్ క్లాస్? ద సింబల్ ఫర్ దిస్ టోకెన్ టు బి యూజ్డ్ డ్యూరింగ్ ద సింటాక్స్ అనాలిసిస్. సో మనం సింటాక్స్ అనాలిసిస్ ఎందుకు యూజ్ చేస్తున్నాం? వీఆర్ కన్స్ట్రక్టింగ్ ఏ పార్స్ ట్రీ ఆర్ సింటాక్స్ ట్రీ. సో పార్స్ ట్రీ ఆర్ సింటాక్స్ ట్రీ మనకి రావాలంటే సో దట్ ఈస్ ఇన్ ద ఫార్మ్ ఆఫ్ టోకెన్స్. ఓకే. సో స్ట్రీమ్ ఆఫ్ టోకెన్స్ లాగా మనం generate చేస్తాం. సో each and every token it is in the form of token class comma attribute name. So token class is the symbol for this token to be used during syntax analysis. So what is the attribute? So this attribute points to the symbol table entry for this token. Okay. So attribute ఏం చేస్తుందంటే పర్టికులర్ ఫర్ ఎగ్జాంపుల్ లైక్ ఏ సీక్వెన్స్ ఆఫ్ నంబర్స్, ఒక నంబర్ ని జనరేట్ చేసుకుంటుంది. So that is generated number can be represented to the symbol table. So it is points to the symbol table entry for this token. So ఆ token కి మనం ఒక నంబర్ అనేది ప్రొవైడ్ చేస్తాం సింబల్ టేబుల్లో. సో ఫర్ ఎగ్జాంపుల్ లెట్ us కన్సిడర్ an example. The tokens for, so this is the equation. So here we are having 4 address codes. So FIN is one address and ININ one another address and rate is another address and 60 is the constant. So this is in the form of 4 address code. So in intermediate code generation, so this can be modified into 3 address codes. Okay. So here FIN, so ఇక్కడ సింబల్ టేబుల్లో మిస్టేక్ పడిందమ్మా POS అని. సో ఇక్కడ FIN పెట్టుకుంటే సరిపోతుంది. ఓకే. So the tokens for FIN is equals to INI plus rate into 60 or, so this can be right in the output of tokens. So this is the given statement of a source program. So this source program is converted by the lexical analysis into like this. So this is the output of lexical analysis. So this is taken as input to the syntax analysis. So lexical analysis లో వచ్చిన అవుట్పుట్ అనేది syntax analysis లో ఇన్పుట్ లాగా వర్క్ అవుతుంది. సో వీఆర్ రైటింగ్, సో ఇది అవుట్పుట్ is in the form of token class comma attribute name. So what is the token class? So ID comma 1. So attribute 1 and FIN. So this is the first one is equals to another token and ID comma 2. So INI is the second one, ID comma 2 and plus is another token and ID comma 3 is rate and star is another token. So 60 is constant. So constant comma 60. So here INI is the identifier, so rate is identifier, FIN is identifier and 60 is the constant. So here we are writing constant comma 60. What is the value of this one? 60. So there is no change of 60. So that means it is a constant. So in this lexical analysis phase, we have to read each and every characters that are present in a source program. Source program means we are writing a program in a high level language. That program is groups them into meaningful sequences. Those sequences are called the lexemes and produces a output of a token of the form token class comma attribute and passes it into the next phase, that is the syntax analysis. And so what is token class? The symbol for this token to be used during the syntax analysis. So ఏ సింబల్ అయితే మనం యూజ్ చేస్తున్నామో సో సింటాక్స్ అనాలిసిస్ లో, సో దాన్ని మనం జనరేట్ చేయడానికి ఈ టోకెన్ క్లాస్ ని యూజ్ చేస్తాము. అండ్ ఆల్సో వాట్ ఈస్ ద అట్రిబ్యూట్ అండ్ ఇట్ ఈస్ పాయింట్స్ టు ద సింబల్ టేబుల్ ఎంట్రీ. అండ్ సో అట్రిబ్యూట్ అనేది సింబల్ టేబుల్ ఎంట్రీలో మనం పాయింట్ చేయడానికి ఈ అట్రిబ్యూట్స్ ని తీసుకుంటాము. సో దిస్ ఇస్ ద given example, the tokens for this given statement. So this is in the form of English language, that is high level language. So FIN is equals to INI plus rate into 60. So FIN is the identifier, INI is the identifier, rate is the identifier and 60 is the constant. So this is the statement. We can convert this statement into stream of tokens. Those stream of tokens are ID comma 1 and so FIN is one token and equals to is another token, INI is one other token and plus is token and rate is another token and star is another token, 60 is another token. So for example in 60 we are ending with semicolon. Those semicolon is also another token. So ఏవైతే మీనింగ్ఫుల్ సీక్వెన్సెస్ మనం జనరేట్ చేస్తామో అవన్నీ టోకెన్స్ కింద వస్తాయి. సో దిస్ ఈస్ ద given source program. This source program is converted into stream of tokens. So this is the stream of tokens. So this is pointing to the symbol table. So one is the POS. So POS means so FIN and second వచ్చేసి INI and third వచ్చేసి rate. So here 60 is the constant. There is no need to specify the here. Okay. So this is the lexical analysis phase. In detail, what is the lexical analysis phase? So we are converting a given source program into stream of tokens. So the main role of lexical analysis is we can convert the given source program into stream of tokens. So that is the first phase of a compiler or structure of a compiler. So what is the next? So it is a Here in lexical analysis phase, we can take the source program and it is moved to the lexical analyzer. So lexical analysis lo lexical analyzer ఉంటుంది. So in lexical analyzer we can generate tokens. So here token is forward to the parser. So what is parser? So parser means in a syntax analysis we are using parser, and so we can convert the given token into parser, and that parser is taken out output to the next phase, semantic analysis. So in this, so number of tokens can be forwarded to the parser and get next token. So for example, one token is converted into in meaningful conversion, that is token class comma attribute, and we can get the next token. So we can request the parser so to the lexical analyzer. So we can read all each and every tokens that are present in a lexical analyzer that can be converted into stream of tokens by using parser. So those can be recorded in the symbol table. Okay. So in this lexical analyzer scan input, right? So what is the role of lexical analyzer? We can read input from input. Okay. So lexical analyzer scan input and remove white spaces. So in this source program, so what is the first we are discussing in lexical analysis phase? We can remove the comment line statements or white spaces, or file. Is there any header files or inclusion files so that can be added to the source program? So this is the first one. So remove white spaces. So is there any unwanted spaces? Those 509 చెప్పమ్మా 509 డౌటా లేకపోతే చెప్పమ్మా. Okay, so remove white spaces. So we can remove the white spaces that are present in a source program and new line characters. So is there any new line characters that can be removed by the lexical analyzer? And identify tokens. So the lexical analyzer can identify the tokens. So we have to create symbol table. So symbol table ఎలా క్రియేట్ చేస్తారు, ప్రీవియస్ స్లైడ్ లో చూసారు కదా అట్లా, అండ్ ఇన్సర్ట్ దోస్ టోకెన్ ఇంటూ సింబల్ టేబుల్. సో మనం క్రియేట్ చేసిన ఐడెంటిఫై చేసిన టోకెన్స్ అన్నిటిని వీఆర్ ఇన్సర్టింగ్ ఇంటూ symbol table. And is there any errors that are generated by the lexical analyzer? Those are notified to the programmer and send token to the parser. So finally output. So output ఏమొస్తుంది? So stream of tokens. Those stream of tokens that can be sent to the parser. So parser means the second phase, that is syntax analysis. So this is the in detail what is the first phase, lexical analysis. So lexical analysis ఏం చేస్తుంది? We can read each and every characters that is present in a source program that can be converted into, that can be groups them into meaningful sequences. So that is the tokens. So we can convert the given characters that are present in a source program that can be converted to the stream of tokens by the lexical analyzer. Okay, so that is the first phase of a compiler, structure of a compiler. So coming to next phase, so that is the syntax analysis or parsing phase. So parsing phase is also known as the syntax analysis. So this is the second phase of a compiler. And here, so here what is the input of syntax analysis? The output can be generated by the lexical analysis, that is stream of tokens, that is taken as the input to the syntax analysis. So here imposes a hierarchical structure on the token stream. So మనకి ఏవైతే stream of tokens ని జనరేట్ చేసామో those tokens can be imposes a hierarchical structure. ఒక hierarchical structure లో we can arrange those stream of tokens into hierarchical structure by the syntax analysis. So that means we are constructing a path tree or a syntax tree. So second point, this hierarchical structure is usually expressed by recursive rules. Okay, so this means what is the recursive rules for the syntax analysis phase? So for example, we are writing a source program in a syntactic manner. So that means we are not following the syntax. We are get the error messages. So అలా ఎర్రర్ మెసేజ్లు రాకుండా మనకి ఒక ఆర్డర్లో మన ప్రోగ్రామ్ అనేది కరెక్ట్ కావాలంటే ఎర్రర్ సింటాక్స్ ఫాలో అయితే రాస్తే ఆ ప్రోగ్రామ్ అనేది ఫ్లెక్సిబుల్ గా ఉంటుంది. సో దిస్ హైరార్కికల్ స్ట్రక్చర్ ఈజ్ యూజువల్లీ ఎక్స్ప్రెస్డ్ బై రికర్సివ్ రూల్స్. సో రికర్సివ్ రూల్స్ మీన్స్ we are constructing a parse tree in this case. So in this we are constructing parse tree means so we are having one root node and we have different root nodes. So for example, we are having a string id plus id. Okay, so in this by recursive rules means we are constructing or constructing a parse tree in this one rule. So for example, we are taking id plus id star id. So this type of string we can get. So we can get this string. We are having a context free grammar. For example, context free grammar ఉందనుకోండి, ఆ కాంటెక్స్ట్ ఫ్రీ గ్రామర్ ని బేస్ చేసుకొని సో దిస్ టైప్ ఆఫ్ స్ట్రింగ్ అనేది మనం జనరేట్ చేయాలంటే వీఆర్ యూజింగ్ ద కాంటెక్స్ట్ ఫ్రీ గ్రామర్స్. సో దోస్ కాంటెక్స్ట్ ఫ్రీ గ్రామర్స్ so we can that is used to construction of a parse tree or syntax tree. So this is the second point. And so here context free grammars formalize these recursive rules, right? ఇందా చెప్పింది అదే కదా. సో రికర్సివ్ రూల్స్ రావాలంటే మనకి కాంటెక్స్ట్ ఫ్రీ గ్రామర్స్ ఏవైతే ఉన్నాయో ఆ కాంటెక్స్ట్ ఫ్రీ గ్రామర్స్ ని మనం యూటిలైజ్ చేసుకునే దాన్ని బట్టి, ఫర్ ఎగ్జాంపుల్ మనం ఈ టైప్ ఆఫ్ స్ట్రింగ్ ని జనరేట్ చేయాలనుకోండి. సో ఆ టైప్ ఆఫ్ స్ట్రింగ్ కి ఫర్ ఎగ్జాంపుల్ వీఆర్ కన్స్ట్రక్టింగ్ టూ ఆర్ మోర్ derivation trees. So to a leftmost derivation or rightmost derivation, those leftmost derivation or rightmost derivations so we can take by using context free grammar. So we can remove this ambiguity. So ambiguity remove చేయాలంటే సో అది నెక్స్ట్ పేజ్ లో చూసుకుంటుంది. So context free grammars formalize these recursive rules and guide syntax analysis to flag syntax error in case of any mismatch. For example, is there any errors that are present in a syntax analysis or a source program? So that can be intimated to the programmer. Okay, so this is the third point. And what is the fourth point? The intermediate representation. So what is IR? Intermediate representation. So ఇది ఎక్కడ ఉంది? 2-pass కంపైలర్ లో వస్తుంది. ఓకే, సోర్స్ ప్రోగ్రామ్ నుంచి ఇంటర్మీడియట్ రిప్రజెంటేషన్ వస్తుంది. ఇంటర్మీడియట్ రిప్రజెంటేషన్ నుంచి మనకి మిషన్ కోడ్ అనేది జనరేట్ చేస్తుంది. సో ద ఇంటర్మీడియట్ రిప్రజెంటేషన్ ఈజ్ యూజువల్లీ రిప్రజెంటెడ్ యాజ్ సింటాక్స్ ట్రీస్. సో ఇంటర్మీడియట్ రిప్రజెంటేషన్ అనేది సింటాక్స్ ట్రీలో యూజ్ చేస్తాము. అండ్ ఇంటీరియర్ నోట్స్ రిప్రజెంట్ ఆపరేషన్స్ అండ్ లీవ్స్ ఆర్గ్యుమెంట్స్ ఆర్ ఆపరేషన్. సో మనకి ఆపరేషన్ ని ఎక్కడ రిప్రజెంట్ చేస్తారంటే ఇంటీరియర్ నోట్స్ అంటే ఫర్ ఎగ్జాంపుల్ రూట్ నోడ్ అలాగా డిఫరెంట్ నోట్స్ ఉన్నాయి కదా, ఆ నోట్స్ లో రిప్రజెంట్ చేయడానికి మనం ఆపరేషన్స్ ని యూజ్ చేస్తాము. సో లీవ్స్ కింద యూజ్ చేస్తాము. ఫర్ ఎగ్జాంపుల్ ఇన్ ప్రీవియస్ ఎగ్జాంపుల్ ID1, ID2, ID3, ID కాన్స్టెంట్ ఇస్తున్నారు కదా. సో ID1 is one leaf, ID2 is another leaf, ID3 is another leaf, and constant is another leaf. So in this way we are using leaves and functions or operations. So for example, addition, subtraction, multiplication ఉంది కదా, so those can be used as the notes for the next one. Okay, so this is the syntax analysis. So what is the what is the role of syntax analysis? So we can get output from the lexical analysis, that is syntax tree, sorry, stream of tokens. Those stream of tokens can be generated by using context free grammar rules, or we can develop a one parse tree for this given program. Okay, so these are the 3 points. Imposes a hierarchical structure on the token tree, And second one, this hierarchical structure is usually expressed by recursive rules. So recursive rules means context-free grammar formalize these recursive rule and guide syntax analysis to flag syntax errors in case of any mismatches. Okay, so this is the syntax analysis phase. So in the previous example, how to construct a syntax tree. So this is the syntax tree for the given example. So parse tree for fin is equals to ini plus rate into 60. So this is the parse tree for given source program, and here tokens are, so we are generating given statement is source program, and it is converting uh, those source program into stream of tokens. So those tokens are id comma 1 and equals to is another token, and id comma 2 and another token plus is another. So in this way we are getting the tokens from the given example. So we can construct a source program, sorry, we can construct a syntax tree or parse tree for the given example. So this one is the syntax tree or parse tree for the above example. So equals to, we are using the nodes. So we are using the operations as the nodes, and we are using functions or functions that can be used in the leaves. So equal to is the function, equal to is the operation. So we are using equal to id comma 1. So this is the leaf node and this is the root node. So plus, so plus is so in this equal to is first one, and id comma 1 is one leaf node, and before going to write id2, so we are having one operator, that is plus. So id comma 2 we are writing, and id3 we are writing star. So star into id comma 3, and what is the last one, 60 is the constant. So in this way we are constructing a parse tree. Okay, in this way we are constructing a parse tree for the given example. So given example or given source program. Okay, so this is the parse tree or syntax tree for the given example. So here we are using actions extracted by the token order. So ఒక token order అనేది ఎలా జనరేట్ చేసుకోవాలంటే by using some context free grammar rules. So we are constructing a derivation trees. So derivation tree అంటే ఏంటి? So we can get a string. We can get a string in a lower order or upper order. So top down parsing చేసుకోవచ్చు, bottom up parsing చేసుకోవచ్చు. So top down రాసిన bottom up రాసిన we are reading the string. Okay, so in this way we are constructing the parse tree or syntax tree. So in this after writing the syntax tree or parse tree, so update symbol table entries. So ఇలా రాసిన తర్వాత symbol table entries ని changes చేసుకోవాలి, update చేసుకోవాలి, and create abstract representation of source. So we are creating abstract representation means, abstraction means we are hiding some features, and some features are displaying to the user, and hide some essential features. Okay, so that is the abstract representation of source. And is there any errors? That means we are constructing a parse tree. Is there any errors? Those errors can be generated and notified to the programmer. So this is the second phase. What is the second phase? Syntax analysis or parsing. So what is the role of this phase, syntax phase? So we are converting the stream of tokens into syntax tree or parse tree by using some rules. Okay, so that is the second phase. So that is the syntax analysis. And what is the third phase? Semantic analysis. So semantic analysis is also known as context handling. So context handling means so we are using context free grammar. So we are verifying the given syntax tree is syntactically verified. That means so it is following the all the rules that are present in a context free grammar, and the parse tree is correct one or not. So we are verifying in the syntax analysis phase. So here in this one, collect context. So that means collect context. So the output of syntax analysis is taken the input of semantic analysis. So that is collect the context information from the syntax tree and symbol table and check the semantic consistency with the language definition. So context free languages ఉంటాయి, context free grammar ఉంటే that context free grammar having context free language. So ఆ language definition లో కనుక so that is so this is the syntax analysis. In this topic we are discussing in the next class. Okay.